So question 7 is a 2-sample t-test. So we have the sunflower producer who is comparing different types of fertilizer. So the first one is to state the alternative and the null hypothesis. So here we go. So the alternative and the null, we use the notation H0 and HA or H1, whichever you prefer. And the null hypothesis is always that the mean of fertilizer A and the mean of fertilizer B are the same. Okay, so the null hypothesis is always the assumption that there's no difference at all and that both things are the same and we can't draw off any differences. The alternative hypothesis is what we're trying to show. So in this question, she doesn't know which is going to be bigger. It's not like we've got a new fertilizer B that we think is better. We don't know. We're just trying to work out if they're the same or not. So it could be on either side that we're looking. So it's what we call a two-tailed test. But all it means is that fertilizer A is not equal to fertilizer B. So sometimes you would have one being less or more than the other. On this one, we don't know which way round. We just know that they're not equal. So that would be the 2 hypothesis. And then for part B, I need to calculate the p-value for the test. Okay, so the p-value. So to do this, I'm going to go onto my GDC and I need to put the information in. Okay, so I've got fertilizer A and fertilizer B. So fertilizer A, I'm just going to put all this information into the table. It does not matter that one of them is bigger than the other. We can have the lists either size. It doesn't matter at all. It's not going to change my answers. Okay, so there's the data that I've put in there. And then we're going to go to menu, statistics, and statistics tests. And we have a t-test, okay? Now we actually have a 2-sample t-test, okay? This is the only type we do in the IB, and it's 2 different samples that we're looking at together. And we have the data that we've put in. The statistics is only if you don't know the individual values, but we do, so it's the data. So the first list I called A, the second list I called B. The frequency we leave as 1, and the alternative hypothesis is correct. We want it not equal. If not, you would need to change that. You have to put pooled yes, and then we can click OK. So pooled has to be yes. So the p-value there is 0.14605. So the p-value, is equal to 0.146051, or to 3 significant figures, 0.146. So that tells me that it's like 14.6%. And then we need to state the conclusion to the test. So the easiest way to do this is to sketch it. Okay, so we have our value, our rough distribution. Okay, it's not a very good drawing there. And we're interested in a 10% level. Okay, a 10% level. And we're actually looking at both sides. Okay, so 10% level both sides, which is kind of like a 5% level either side. Okay. And my value is 14.6. So 14.6. So half of that 14.6, because that's obviously used both sides, is going to give me 7.3. So the area is 7.3, which is actually bigger than 5%. So it's going to come out to here somewhere. So it's bigger than 5%. Okay, and the same on this side. And that's going to be my like critical value. Okay, that's the region that I've got. which is 7.3%. Now it's a little bit more complicated because it's a two-tailed test, but to be honest, even if you forgot and you drew it the same as normal, and you just said that you have this value, and it's normally 5%, but 10%, and you had a value of 14.6%, you would still get the same answer. Okay, either way, we can see here that this is the cutoff, the critical value, this point here. Anything this side is the original hypothesis. It has to be more extreme than these values to become the alternative hypothesis. Okay, so whichever way you look at it, if this was the cutoff, H0 and then HA, whichever way you're looking at this, it is in the safe zone, if you like. We're not sure enough. There's a 15% chance almost of it happening. So we're really not sure that this is making a difference. It might just be coincidence with the values, and therefore we accept H0. Okay, so we accept H0. And there's not enough evidence. So not enough evidence to take HA. Okay, so there's 2 marks there. 1 mark is for the accepting of H0, but you don't get that mark unless you've also given the reasoning. Okay, so you have to have the reasoning there as well. There's 2 marks, so that's just for stating the p-value and having it correctly rounded, and then there's 1 mark each for the hypothesis there.